Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Once again, welcome to a new problem. This time we have a closed surface with a flat top, and the body of the surface is curvilinear, also with a flat bottom. And so the radius at the top, which we're going to call RT, happens to be 2 centimeters. Always possible to transform that to meters by changing it to um, 1 meter being equivalent to 100 centimeters. So 1 by 100, and that gives us 0.02 meters. Um, at the top, we also have a magnetic field that's equivalent to 0.30 Teslas. And then also the flux coming out of the bottom of the closed surface uh, is equivalent to 0.70 microweber. That's the information that's given in the first part. We want to find the magnitude. And then in the second part, we want to find the direction. And by direction, it simply means either the flux will be inward or it's going to be outward. And this is obviously the flux through the curved surface. Okay, flux through the curved surface. So that's what we're looking for in this particular problem. We'll still use Coulomb's law as part of the problem. And the first thing we need to get is the area at the top, which is the pi r squared, pi radius at the top times squared, which is pi times the radius at the top is 0.02 meters. When you square that, you get 0.001256 meters squared. And then we don't stop there because we want to find the flux at the top. And that's equivalent to the magnetic field at the top times the area at the top. So we have 0.30 Teslas times the area that we just found, which is 0.001256 meters squared. And that gives us 0.37 microweber. So now we have to take these two fluxes, the one at the bottom and the one at the top, and then put them together. And so we end up with 0.70 microweber plus 0.37. The other one was 37 microweber for a total of 1.07 microweber. So we're adding the flux at the top and at the bottom. Now the sum of the flux, magnetic flux, or what we call the net flux, has to be 0. And that means that the flux through the sides is going to be negative 1.07 microweber. The reason why it's negative is because when these two cancel out, you get a net flux of 0. That helps us find the magnitude, but A of the flux is equivalent to 1.07 microweber. And then part B, we have to find the direction of the flux through the curved surface. So the direction is going to be inward. So hope you enjoyed the problem. Feel free to send any questions or comments and have a wonderful